as we were seeing the challenges in distributed systems. Some of the challenges we have already seen. Now we are about to see the challenge related to scalability. What we have to understand is the system that we usually have, in maybe we call it distributed system. So it may be within a small area, a small intranet we may have, or it may be distributed on internet, which can go through the continents as well. So here what I am telling you is after other possible challenges, as we have seen security and openness, or maybe heterogeneity we have already seen. Here we are thinking about scalability, that we want the distributed system to be scalable. What it means, scalable systems are such systems which will remain effective, or I should say efficient and effective, even if the scale is improved. Scale is improved means more number of systems are added, or more number of the service that we were giving is improved, means number of enhanced, okay, number of users have increased, that kind of things, and accordingly we have increased our capacity, our power of the system. Okay, actually what we think, as we have seen earlier also, what do we do for making system scalable? In place of adding a replacing the existing system with a more powerful system, what we do is we add a smaller system with the older, smaller system. In that case, what happens? Our system has a potential of growing. Okay, and the thing is, what we are thinking that our system is scalable, it means we have set of softwares which are operating on the system, and even if we are adding more components in the system, the software needs no changes and it can work in the same way as it was working earlier. It is effective as well as similarly efficient. However, for making such a scalable system, there are certain difficulties. The first thing is controlling the cost of physical resources. We can understand that we want to add more resources to the system, no problem. But maybe as we are adding the number of systems, accordingly the cost is also increasing, right? No problem. But the thing is, the cost that is increasing should be within a limit. Okay, so always we have to keep in mind that the cost that we can afford is limited. Okay, so now the second difficulty is controlling the performance loss. It is true that we will add new components to the system, no problem. But we can understand that when we were having just one component in the system, then all the information was on this particular system only. Later on, now if we are adding more components, then information is on different component as well. Now when you are trying to process, you need some information from here and some information from there. And whenever there are two components, there is interaction between them, whatever means we use, but there is time consumption. Okay, and whenever this time is used, this is extra time. This extra time means performance loss. Whenever we have performance loss, we have to control it, right? So making a scalable system is not that straightforward. We will need to keep this thing in also in our mind, that we have to control the performance loss. We understand that there will be certain loss of performance, but we will have to try to keep it as minimum as possible. Okay, so that is the thing. And the third point is preventing software resources running out. Software resources means, suppose earlier what we were having, IP version 4, right? You remember? So it can be considered as a resource, what should I say, software resource kind of thing. Okay, so later on we have IP version 6. Similarly, if we are having certain this kind of resource we are using, with the scale of our system, if that particular resource is going to be exhausted, which is not available anymore, in that case we should take care of that particular thing also, that we should make a scalable system which should not exhaust the resources, software resources. Other point is avoiding performance bottlenecks. Bottlenecks, what happens in bottlenecks? Bottleneck means whenever you have a single server, all the resources, all the requests are coming to this particular server, then if this server has to reply all the time, and for all the requests, in that case you can understand that all the requests are coming to this particular server, then it may be less efficient in responding to all the requests. That may be considered as bottlenecks. Okay, let me tell you, this is a neck to your bottle. Suppose you have a distributed system which has lot of capacity, lot of components inside. However, all the requests that is coming should come through this server only. Okay, you are making the system scalable, no problem. You have recently added 2 new servers, no problem. More servers are being added, but all the requests that are coming to the system are coming through this particular node only. In that case, what is happening? For this potentially good system, what you are having a bottleneck. In this system, this is the only entry point, and or this is the point from where the responses are to be given. Input means the inflow will come, outflow will go from this through this node only. This may create kind of bottleneck. So we have to avoid such kind of bottlenecks. Okay. Okay. Now, after this scalability challenges related to the scalability, we are ready to see challenges related to failures. Okay, let me tell you, there are challenges related to handling the failures. Okay, we always understand that failures are possible in distributed system. So we should be ready with certain techniques how to handle the failures, right? We have already seen that the failures in a distributed system, okay, this is the distributed system, means set of these nodes may be connected together are responding as a single system. Okay. So if at all it would have been a centralized system, then what happens? If the system fails, the whole system fails, right? However, in our distributed system, what happens? If some of the nodes are failing, still the other nodes are working. So we call it as partial failure, right? So in case of partial failures, we have to do something for handling these failures, right? First thing that we can do is detect the failures. Detect the failures. Detecting failure means, suppose there are certain kind of failures. One, the system crashes, right? If the system crashes, the traffic inflow outflow through that system is not coming, right? So in a way there is a possibility to know that the system has crashed. There are certain more kind of failures that may occur, which is something like transmission of corrupted data, right? Data was being transferred and somehow something happened in between because the data was corrupted, right? So for those things also you can have something like checksum. These kind of things you have studied. These kind of things can be used to check whether the data which was transferred was correct or not, if it is having any problem. Such kind of failures can also be detected. Let me repeat. We are dealing with the challenges related to the failure handling. So these are certain things we should take care while handling the failure. Whenever we are building a distributed system, we should consider certain modules, certain part of the system, some code we have to write for handling the failures as well, right? However, that part of code is also not that straightforward. The one thing was the data being corrupted. Maybe for that purpose you are using checksum, but several other, like if the system crashes, in that case rebooting the system is only the option, right? No other means. Definitely we will see a separate chapter for failure handling, no problem. But still, let us understand that the system has failed, and since one system here is failing, then there is certain services that this particular node was giving, right? Maybe it was, when it failed at that particular time, it was handling certain clients, some requests it was handling, right? What was the state of those requests? Those are all the things we should take care of, right, while designing our distributed system. So first thing that we are saying that we should be able to detect the failures. Let me talk about masking the failures. Masking the failures. What do you think about masking the failures? The thing is, here we try to hide this problem from the external users. The external users should not be aware that one or more a part of the system has failed. Okay, for that purpose, okay, let me repeat. The external users which are there, they should not be having any problem because of some system has crashed in the, or certain failure has occurred in the system, partial failures. So then what we can do? We should notify the users about the possible resources that they can access and the resources which are not available currently. Okay, है ना? So or something like this checksum that we have already done, whatever ways needed to confirm that the data which are being stored or transferred, they are not corrupted, they are good data. Okay. Now, after detecting masking, can we talk about tolerating failures? Tolerating failures. What does it mean? We are tolerating the failures. Even if one system has crashed, what we are going to do? We are tolerating it. Maybe with if the system was working, we were good at performance, but still we are not that bad. Okay, we are giving the correct services. Let me repeat, correct services with a little performance degradance. Okay, performance has degraded a little, but whatever we are doing is correct, right? Whatever output we are giving is correct. So if that kind of thing we can do, that is still okay, tolerating the failures. Other thing, one is detecting, masking, tolerating, and recovery. Okay, recovery from the failure. Recovery from the failure. So now what you can do? Suppose this failure has occurred. As I was telling you, certain client requests are there which are being handled by this particular system. We have to recover the system. Recovering means the only option was to restart the system, right? If it has crashed, in that case we are restarting the system. Now on restarted system, the states, the older state, what was the old state, if we are able to relocate, or I should say we are able to somehow maintain the older state, what was the old state of this particular system, if we are able to maintain that old state, somehow if we were able to store it somewhere and reuse after restart, and we are able to maintain that old state now, that will be the best. Okay. So maybe for a time being in between the system was not working, but after the system started working, it was having the older state as it was in beginning, before the crash. However, if we are maintaining that old state also, we have to take care that in between, when the system was in crash mode, whether the services, the request that was there lying, whether those services have already been provided by other server or not, okay, other node of the system or not. So we have to keep all these things in mind while the recovery of the system. Some of the transactions which were going on, they failed, and those failed transactions are to be suppose rollbacked, okay, or maybe they have to complete it, no problem. Such kind of things can be done while recovery from the failure. One important thing that can be very helpful in case of failure is redundancy. Okay, redundancy is especially very helpful for failure handling. Suppose whatever data was stored on this particular node was also stored, whatever resources I should say was stored on this particular node was also stored on this particular node. Suppose this was node A and this was node B. So node A has failed, crashed, but node B is working. Okay, so node A which has crashed, all the request that was going for A can now be diverted to B, and all the requests which are coming, they will need not be delayed, they will be served as soon as possible. However, whenever this server, this node is restarted, they should comply with this particular redundancy. Okay, they should update themselves. So that is also a point related to the failure handling. So I want to say that these are the possible related challenges whenever you want to handle the failures in your distributed system. Okay. So till now, if you have certain questions, please go ahead. You can ask questions if you have. Do you want to ask something? 2 points we have seen till now. One was failure handling, and before failure handling we have seen a scaling. Okay. After scaling we have seen failure handling, where we were seeing if a system fails, what are the possible challenges, what can we do, and these are the things which we need to implement in our distributed system. Anything else if you want to ask? So if not, we are moving further. Let me talk about concurrency. That let me talk about concurrency. So we all understand, then where there is a server, we want to allow multiple users to access the resources. When multiple users are trying to access the resources simultaneously, means at the same time, then it is possible that more than one user are trying to access the same resource. When more than one user are trying to access same resource concurrently, then we should take care that the data remains correct before and after the access. So for that purpose, we in a distributed system will try to have certain part of code or module which will take care of concurrency. Okay. Means concurrency should be allowed, but the data should remain correct. That is only what we want to say in concurrency. So this is actually not that easy, but the algorithms are available. We will have to take care of these all sort of thing. Now the other important thing in distributed system that we are going to say is, let me write the name first. It is transparency. Okay. Transparency, basically you have certain components in your system. Users are trying to interact with your system. I want to say that You want to keep it transparent. I believe whatever meaning you are thinking for now, for the meaning of transparent, it may be wrong. Do you want to try? Do you want to guess what transparency can mean here in distributed system?
Sir, allowing more than one user to access the resource at the same time.
Not that correct. Can you say a little more? That is not only concurrency, it is transparency. So it should be something like visibility, what can be seen kind of thing. Transparency, what looks like. How does it look like?
Sir, hiding the complexity of distributed system from the user and application.
Hiding the complexity is a correct thing. What kind of complexity can be hidden?
So basically implementation detail means how networks are connected, or how messages are being transferred, or how two systems are communicating, that.
Something like that. Definitely something like that, but a little different. Actually, in distributed system, what do we have? We have these components. They are connected together, no problem. So whatever resources we are offering through this distributed system, they might be residing in partition across these nodes. Okay, no problem. Some of the nodes may have redundancy, no problem. Okay, some of them would be high in, maybe computation was good, some of them were not that computation efficient. Whatever, these kind of things may be there. The only thing here what we want is the external users should believe that they are interacting to one system. They are totally unaware that internally it may be having more than one components, more than one nodes working together to provide the services. Okay, so this is definitely a definition of transparency, and this is something which we want to achieve in the distributed system. However, it may be not that easy. Okay, let me talk about certain a little more detail on transparency. There is one document, you call it it is International Organization for Standardizations. reference model for open distributed processing. Now what is happening here? So iOS is a reference model for open distributed processing. You can call it as RM ODP. So these people at iOS, they have find out some of the forms of transparency. Okay, forms of transparency. No doubt more kind of transparencies can be identified and named, no problem. However, here we are going through these forms of transparencies. Basically, I should say they are 8 in number, given by these people by this reference model of open distributed processing. So let me name the first one. First one is access transparency. So what happens in access transparency? Whenever you want to access, they should not be aware that the data is being accessed from where, from which node particularly. Suppose even in a distributed system, these nodes are there. When they are trying to access the data, they just know the name of data and they are accessing the data. They are totally unaware that the data that they are accessing, the data is local or the data is coming from a different server, different node. Okay, so that kind of transparency will be called as access transparency. Whatever they are trying to access, they are totally unaware that whether it is from where the data is coming. Okay, even if they are insiders, they are unaware that the data is local or the data is from some other node. There is something called location transparency. What happens in location transparency? It means we don't need to know the actual address of the data. Okay, the data can be accessed without the actual information, without the knowledge of their physical location or their network location. Okay, it doesn't matter where the data is. Another thing is concurrency transparency. What can happen in this concurrency transparency? There would be certain shared resources and there may be processes which would be executing concurrently. These concurrent processes may be using the shared resources. However, they should be totally unaware that the data is being shared means we are accessing the shared resources. Okay, let me say it in a way that the shared resources should be available to all the concurrent processes without any interference between them. Okay, now another thing that I can say is replication transparency. Transparency. Okay, so in replication transparency, the name itself says that there might be certain replication in the system. However, the users or the processes should not be aware of this replication. It should not be visible. It should not come in knowledge of these processes. Okay. Now let me talk about failure transparency. What about failure transparency? When we have failure transparency, okay, whenever we have failure in our system, we want to hide this information, hide this thing from the user. We want to give the user a good experience with our system. So whatever needed, if at all we are able to mask it, we will do it. If we are able to whatever we can do for handling this failure, we will try to do, and we will try to give the user a good experience even with the failure. Okay, the failure is what kind of failure, whether it is hardware failure or a software failure, no problem, but we assure the user that their task, whatever they have given, it will be completed within a specified time, or maybe we will not specify the time, but still it will be completed, no problem. Failure has occurred, but nothing to worry. Then the next kind of transparency is migration transparency, right? In the book, we are also calling it as mobility transparency. Mobility transparency. What does it mean? We want the resources which are at one node, it may move from one node to other. Okay. But it should not affect the performance of the system. Whatever processes are running, they should be accessing the data, accessing the resource. Now the resource has moved from one node to other, one place to another place. The internal physical address, physical location may have changed, but still the processes, the running processes need not be modified, need not be in any kind of problem. Okay. The next kind of transparency, the next form of transparency can be considered as performance transparency. Performance transparency. So what happens in this performance transparency? Suppose in your distributed system the number of users has suddenly increased, more users are there, more processes are running. Then if you want to improve your system, you should be able to improve your system without making any change in the software interface. Means what I want to say, more the load has increased, more number of users are trying to access, but at the same time you are able to serve all the requests. If you are able to do that, it is performance transparency. Okay, so dynamically you have improved the performance. That is what we are talking about. Another thing what we are having, another form of transparency, it is scaling transparency. Now as we have already seen the scaling, we want to add more systems, more more resources to our system. Because of that our system will be expanded, but we need not change the system structure or any kind of algorithm, those kind of things. Okay, whatever software that we are using, it should not need to change because of scaling the system. Okay, that is scaling transparency. So that was the all 8 forms of transparency. Here you can understand that access transparency, location transparency, it remains the most important part of this transparency. That these are the very important thing that should be that must be there in a distributed system, that very carefully designed. There it should be access transparency and location transparency. Okay, now that was the case. If at all if you have certain questions till now, please go ahead.